Hello, everyone. Welcome to my talk. I'm really happy that you've picked mine over the second one, which is also very interesting. I'm honored that you're here. Yeah, this is the first talk for the design track, and I hope you're going to enjoy it. And thank you for Klaus for giving me this honor for opening the design track, which I think is an awesome track in this conference. All right, so this talk is pretty, let me just see if I can, okay, cool. This talk is pretty, it have a lot of details. I'm trying to go over a lot of things here because this is a review. And it's not gonna be easy considering I have 1 hour. So I'll try to stop for questions, but do take this under consideration. And additional thing I want to say is there's a lot of details in the code. Feel free to ask questions about them, but also we have a lot to cover. So all of the code snippets are going to be in the slides deck, and I'm going to publish it later. So feel free to also go there and explore. So yeah, so I'm a software developer at Millennium. I'm also an active member of Workgroup 21 as Library Evolution chair. Workgroup chair and the Israeli NB chair. I'm also involved in I'm also a board member for the ISO C++ Foundation, which is basically the foundation that organized this conference. So I'm, again, really happy to see the conference going well. And Boost Foundation, which is the foundation behind CPP Now. Happy to see you on both of those. So I love software design. And I also have a passion for cataloging, and this is why I made this talk. I really think that we should have more consistency in C++ world in general. So, all right. So the talk is going to be as following. We're going to start with talking about what is a library. Why is this important in my mind? Then we're going to move to customization points. Now, customization points is not necessarily widely known term. So if you haven't had a chance to hear about it, if you're programming in C++ for 20 years, that's perfectly fine and acceptable, because this is not a term that's like, you don't necessarily stumble across it. So I'm going to also define what it is here. And then we're going to compare different customization points method that we have. Again, this is a talk that's do a survey, so we're going to go through 8 of them, and it's going to be quite quick. And I hope you're going to get at least some of the future of what's next for this aspect. And I think it's again, I think it's a major topic. So cool. Yeah, and some of the topics will also contain some history about this. So let's start with what is a library. So I have here an example that's oversimplified one, and I have a logger library being written, for example, by Alice in one part of the world. And Alice wants to know how to log the type that's been written by Bob, the planet. And it's not something that Alice can tell by, when she wrote this library. It's something that Bob have the information of. So the idea of being able to communicate between library authors and library users or application programmers, however, by the way, in this talk I'm going to refer, users are going to be the people that use the library that's been written, and that could be also application programmers, it could be something else. It doesn't necessarily restrict it to the standard library, by the way. Even if you write a library in your workplace, that's also relevant. But we need to get some information from the user, and this is not a trivial problem to solve, right? So this is something that I'm sure a lot of you have already stumbled across. We have a logger, we have the output operator, and Bob basically defines the output operator, and then we can have the behavior that we want. Bob can now log planets, right? Generally speaking, during the talk, I'm not going to refer to namespaces because this is a slide code, but whatever on the library side is on the library namespace, whatever on the user side is the user namespace, generally speaking, and if not, I'm going to point it out. But I think this slide really tries at least to explain the problem that we have, right? And why is it so important? All right. So a library is a collection of non-volatile resources used by computer programs, often for software development. But library is important to me to emphasize, especially before we start talking about customization points, that it can be shared between different developers, often from different parts of the world that never met. And they have the best way that they can communicate is either documentation or customization points. So this is very important to keep in mind. It's not necessarily the person in the other, in the other room that you're working on the same company with. It can be, especially if you're taking things from standard library or open source, it can be people that you never talked with, right? And communication is a challenge. And customization point, as I mentioned, is the thing that addresses this challenge. So the term was first mentioned by Eric Nibbler in a blog post from 2014. And then it was mentioned in 2015 in a Workgroup 21 paper. So according to Eric Nibbler, by the way, the person behind Ranges v3, which was later being done, made into Ranges for the standard library, a customization point, as will be discussed in this document, Eric's paper, is a function used by the standard library that can be overloaded on user-defined types in user's namespace and that is found by argument-dependent lookup. But this is pretty narrow definition. So in this talk, I'm going to use something a bit wider, all right? Because I want to survey different ways to do this, and this is what Eric been referring to back in 2015, but we have other things as well. So in this talk, customization point is a way to integrate library and user code and allowing the user to customize or hook the library according to their needs, just like we saw in the first slide with log. And we will review the customization points Eric was referring to, and we're going to refer to them as original customization points. So we've now reached our first takeaway. Customization points are a means to integrate library and user code. So users need to be able to understand which customization points exist and to be able to opt in, add their own implementation, just like we saw with the logging. They also need to be able to avoid accidentally opting in, running over library implementation. So Barry Resvin talked about those aspects in a great paper that I really recommend everyone to read. We need the language mechanism for customization points, and this talk is going to take a very close approach. But we now reach our second takeaway. Customization points are a means of communication, and I can't emphasize that enough. We need to be able to communicate between the library and the users. And as I mentioned, customization points are a way for the library author to also communicate with the users, not just the users of the library. So we need to be able to tell the users which entities are actually being provided by the library, right? So we could, like, for example, you could provide a library that does some of the implementation, that have a default implementation, and the users can take this and build upon this. And you don't, like, we're going to see a few examples that are going to take some of the library implementation, default implementation, but some of them are going to run over the library implementation. And this is an important aspect that you need to take under consideration when you pick a customization point method. So, as I mentioned, we'll focus on users, application developers, etc. There's also libraries using other libraries, but that's a different story. But approximately the same, but still. So customization points are means to embed specifications. So to summarize, our first takeaway, customization points are means of integration. Second one is customization points are means to communicate requirements. And customization points are means to embed specifications. Any questions so far? And this has been, this is a major part of the talk. Before I go deep into the details, I want everyone to feel comfortable with what we're trying to achieve here. Cool. So again, we're on the design track. And I want to emphasize that designing of a library contains a lot of details, a lot of different topics. And customization points is one of them. And this is the way, I look at it. Of course, you may have a different view, but error handling or execution model are also things that you need to take under consideration when designing a library. I'm not going to refer to them here, but I want you to be aware that, we're not going to cover everything, and this is a narrow topic, but it's still important in my mind. All right. Anyone have comments or questions so far? Cool. By the way, how many of you have written a library in your workplace or, for open source projects? Oh, wow, okay. That's perfect. All right, so you definitely know what I'm talking about. And I just wonder, can you raise your hands again? For those of you who've written a library, how many of you have written a library for someone that is not in, that you can't actually communicate with by, in person or... So basically you understand what I'm talking about. But yeah, it's hard, right? It's hard. Thank you for that. All right, so let's start. C++ was born with a customization point method and more were added over the years. We will scan through the following. Inheritance, class template specialization, original customization points has been addressed by Eric Nibbler using ADL. Customization point objects, which is what Eric actually proposed as an answer to 3. Concepts that we have, and tag invoke, which is not in the standard. Customizable function, which is not in the standard as well. And reflection, which is not in the standard. But we're not going to focus on those long. Still, I wanted to bring them up. And I hope that by the end of the talk, you'll review those as, you'll be able to evaluate in their upsides and downsides. So as I mentioned before, we'll skip through some of the details because this is a lot to cover. But the code snippets are in the presentation comments, and I'm going to publish the presentation. I'll be happy to, feel free to go in and meddle with it. So let's start with inheritance. We have here a logged type in the library side, and the log type basically defines some functionality and data and terminology. So we can either say that we want a mandatory, something that have to be overloaded by the users, or we can say, we already have some default functionality, like for example, for pname. We can also define terminology. I call this terminology, using name, etc. This is like a terminology that we expose, right, for one that inherit from us. And there's also a member in this example. So as I mentioned, we can either define a pure interface or optional interface. And then we can build upon this functionality because now the library knows that whoever inherits from log type have at least the default functionality, and we can create our algorithms based on that. Now, I know you've been seeing, inheritance, you've seen inheritance before, but it's really important to me that you'll focus on the aspects of customization points in, approaching, in this approach, and this is like an exercise, right? So, again, we can build upon it. Now we can write log algorithm because we know that we have pname to call. That's significant. On the user side, user can inherit this log type, of course, and they gain this customizable functionality, data, and terminology, which is important, by the way. Not all of the customization methods that we're going to see are going to allow this. This is actually quite cool approach. And users can pass this user type, in this example, spaceship, so we're going to log spaceships mostly. And they can pass it back to the library to basically the log that we wrote because we know we have pname default, right? So now I'm gonna, throughout the presentation, I'm gonna talk about the characteristics of each method. And again, I think that inheritance is a really strong candidate in this aspect. By the way, I'm going to ask for hands raising for your favorite customization point methods. So I hope you take notes. Yeah, so we're able to share interface functionality, data, and terminology as a group, which is important. And it's easy to opt in. It's hard to accidentally opt in. We know, we can override, etc. We know what we need to opt in into. And it have, some limitations, maybe limitations on return type. Covariant return type can solve this, but I don't want to go into all the details of, the different ways of doing this. But it's definitely interesting that there's a few variants, and it's non-intrusive into the library namespace, but it is intrusive into the type. So now, let's say I have this logger library, and I want to be compliant with it. I have to now implement pname. But what if I have more than one library? I have logger library and I have, I don't know, fuel library. That means that my type needs to be able to be conformed to all of those different libraries, and this is some burden over the type, right? So that's another interesting aspect to consider. And examples are, of course, everywhere. Right, so we're now warmed up, and we're now going to move to other things. Class template specialization. So here I'm going to show 4 different versions. And I mean, I want you to separate the technical terms, like, okay, this is the class template specialization, of course, but I want you to put aside the fact, the technical detail of how this thing is, and address the properties it have as, you know, as being a customization point. Because that's why I showed 4 different examples, because it doesn't really matter. It's not exactly the code that we write, you know, like the technique that we write. It's the meaning for, you know, how do we connect. So it's an important thing to understand. It's not all class template specializations methods are providing the same interface. So let's see that. So in this example, library defines a template class container, and I'm sure you've seen such examples a lot using the standard library. And library defines sort function with partial ability to restrict that. We can use concepts later. I'll talk about concepts later, etc. And we call sort. Again, we know that we have some terminology and functionality because we instantiated a template. On the user side, users have their own struct, and of course, they can create a template specialization of this specific type, container, like we do in the standard library, right? This is very common. And we know that we have the functionality at, and we can also use this functionality to basically build upon using sort, because we have iterators. All right, so let's move to the next one. Of course, this is, as I mentioned, being used for containers of the standard library behaves like this. Now we have a different version, and it's still class template specialization, but it's a bit of a different one. So now we define a log type, but we have a default constructor. It doesn't have default, so we can't actually instantiate it, right? And library defines this logged type, and library defines log function that only takes, in this example, log type. So users can override the entire implementation by template specialization, right? So now I can have a log type and have a specialization for spaceship, right? And I now lost all the things that were in the template class. And this is a different behavior than what we saw before, right? Before we were actually able to get some of it. So as I mentioned, we can instantiate it. And this may look a bit strange, but this is actually the behavior that we can see in FMT library, right? So we get the limited external long functionality. A third version, still using class template specialization, still doing something a bit different, is this one. So we can define this log type with deleted sitter again. But now we can actually have some of the functionality being transferred. So what we're doing here is actually specialize specific methods within the template class. It's a different thing than what we saw before, because now we're only running over some of the behavior. And we, as I mentioned, yeah. Right? And we can now instantiate and use this log type spaceship, but we get some of the behavior being transferred, etc. Sorry, this ran over. And again, we can get the second level functionality like we saw before, right? Because we know that we have pname. But we need to, right. Sorry, yeah. So for the second example here, as you can see, of course, we get the behavior that the user implemented, the Apollo 1, the pname that is being implemented by the user. All right, cool. And now we're going to see the fourth version, and again, the same technique, but different behavior. We have a logger, and we have, we're going to write this functor. Logger have the operator parentheses, and we can basically delegate to the user in this example. And again, don't feel, you don't have to go over through all the details because there's in a code snippet, but if you have a question, feel free to ask. So we have, again, the implementation that delegates to the user. So what you see here is that I have an operator parentheses. I do A. This is the library, right? The library says, before I call the logger, I want to do A. And do A can do whatever. It can add additional logging to the behavior. It can do something else, right? And then we return this logger. The last line in the square that you now see is the thing that basically delegates to the user, right? Now we have return logger, and then the user writes the operator and have their own implementation be imported. So again, template specialization, but a different behavior. And now we can actually instantiate the two different things. We can create a default logger with int that, it's not a user type, it's just int. It doesn't comply to this to the interface. And we have a space logger, which is the user implementation, and we can use both of them. And we provided this functionality of logging for different types of users. All right. So I'm going to summarize this, the four different methods, and I'm sure you can come up with other things as well. I'm going to summarize the characteristics of this of class template specialization. So again, this is name or type intrusive. Default implementation can be provided, like we just saw here. If defaults exist, we can basically. It's kind of hard to prevent the user from running over it, but it still can be provided. And there's no mechanism for verifying the interface behavior. So if I would have provided something that doesn't implement the functions that I need, it's limited. But this is exactly what we see both for the standard library. The first version, as I mentioned, is containers, right? This is exactly how they behave. And FMT library is basically using the second version that we saw, the class template association that runs over the implementation. So this is very common. It's not something, it's not just for the presentation. All right. Any questions so far? Cool. So we'll now look at the original customization points by ADL, as I mentioned, being the original way to do things before Eric came up with his ideas. Before I talk about ADL, I want to introduce what is ADL. So let's talk about overload resolution by the compiler very briefly. So the compiler, to compile a function call, the compiler creates a list of candidates. And we then need to find the right overload to be called, right? So this is called overload resolution. Function candidates picked by name, and they may include template argument deduction and argument dependent lookup. So what are template argument deduction and argument dependent lookup? Template argument deduction is the function template with the same name can create additional candidates for the overload resolution. So the compiler have, let's say I have a log function. It's a normal void, a function that returns void and is a log. It's called log, and it takes, int. So this is one candidate. But if I also have template function, templated log function takes a type, maybe restricted by concepts, maybe not, probably should be, then we have additional candidates for that. And the point that I want to make here also important is that it's not only that the compiler search in the scope of the call site of where we actually call the function. They also the compiler also search in the argument namespace, right? So This is important to realize because this is a technique that's, we keep stumbling across, and this is across the library, the standard library is being heavily used. So of course, namespaces are order and arguments are not order. So if we get some ambiguity, we may get a fail. That's fine. So to summarize, to compile a function call, the compiler must first perform name lookup, which may involve argument-dependent lookup, and for function templates may be followed by template argument deduction. And if we have more than one candidate, then we need a resolution, and we may fail, of course. Cool. So now we know what argument-dependent lookup is. All right. So customization points. Where's my time? Right. 34 minutes. Cool. So customization points, as we discussed by Eric Nibbler, this is the way they behave. Basically, what we're counting on is that the overload resolution will pick the correct candidate. This is the ground rule that we're trying to achieve. And here in this example, I write log function, and I have additional log function. The first one is restricted. This is before concepts. We're going to talk about concepts, but I just want, ignore the specific syntax. I just want to say the first one can only work for something that has name function, that basically implemented the function called name, right? And the second one works generally. And what we're trying to do is rely on the fact that the overload resolution is going to pick the right candidate. That's basically what we're doing when we're talking about ADL. User gets different behavior according to the properties of the type, of course. So, if we implemented the thing, then we're gonna, the spaceship is gonna be picked up by the second implementation, right? Sorry, the first one, which is good. That's what we're hoping for. And as I mentioned, we don't only have to implement things in the namespace, external namespace. We can also do this by ADL. And we're gonna talk soon about this, but there's a lot of things that can actually affect the overload resolution process. And this is a major, I think, a downside for using ADL to design your library because it's, it can be very, very challenging both for the users and the people that write the library. It's basically, again, basically being determined by the compiler, right? And it's open to a lot of issues. So we can affect a overload resolution by ADL, or by template specialization in closing namespace, or by template specialization in library namespace, or by non-template function in user space. All of those things are actually going into the list of candidates that the compiler looks at, right? And yeah. Or by using friend that I'm going to talk about. So this behavior is complex, and that's, I think, the major downside. So let's talk about a real-life story, swap. If anyone ever tried to specialize the swap for their own types, you've probably been seeing this before. But let's look at what happens in Stack Overflow. So this question been asked 14 years ago by now. It's this presentation from last year. And basically, user asks, I know I can customize swap for my own type to be used by the standard library. How do I do this thing? So someone answers, you need to basically create a friend function in your class that's called swap, and that's your solution. By the way, notice that the person's name have been erased. That's actually, you can find this online. But so then someone answers, a bit later in 2003, it's best unspecified. Most implementation use ADL to find swap, but it's not actually guaranteed, blah, blah. Of course, remember, the friend function is basically aiming for being, located by ADL. A second person answers, I would be surprised if that implementation still use ADL, etc., etc., etc. Now, I'm going to tell you that those people are actually committee members. and this is 14 years ago, right? And you can see how complex this topic is, and people, are in disagreement. Someone suggested that GCC may not be compliant to the C++ standard, which is great. Not the case, by the way, as far as I know. Then to summarize, those people keep been arguing about this, eventually say, you know what, we don't agree a lot of things, but we actually agree on this one. Great success. And some more discussion. And then at the end, this one was published February last year, right? So you can see 14 years of discussion here. And this person S, which I call some poor soul writing code in C++, have only one question. What is the purpose of this friend here? Okay. So, I think this says a lot about this mechanism that we provide.
Is this still the recommended way to do it, though?
Yeah, it is. But sorry, who asked the question? Oh, hi, Shaka. It is still it's not the recommended way for new standard library facilities in my mind. And we have other things. Maybe we'll get one of them to 26, and I'm going to talk about it. It is the recommended way if you're, using library, if you're using std swap. If you're using ranges, std ranges, then, ranges swap, then no. Well, we're going to talk about it. So generally, let's break this thing into pieces because I think, I hope it helps us comprehend the problem again. So we have this log function again, and we define this utility log, and utility can be used by logger. And on the user side, they override the implementation to be discovered by ADL, argument-dependent lookup, either by free function in the user's namespace. Again, remember, like the right side is the user namespace, or by a friend function. So the friend function is basically being discovered by the enclosing namespace. That's the secret here. That's the thing that we utilize. If you write a class, all right. So here, this example, the user defines the spaceship class, and then they write this log function, a free function that takes spaceship. So first, library is going to be able to actually see this, right? Which is great. But what happens? What else we can do is write this as a friend function within the class. And this is better than having this as a free function because basically it helps the compiler. Compiler, whenever it resolves a log function, whenever it resolves the name log, it doesn't have to go over through, if we had like different types of spaceship, we have spaceship 1, spaceship 2, spaceship 3, and all of them are right in the log function, then if we're doing it like this, we're basically making this easier for the compiler. So yeah, this is the recommended way if you need to integrate with libraries or parts of the standard libraries that have been written before we had the new things. Or maybe the C++ 26 new things, hopefully. And there's a term for it, so if you want to Google it, it's basically called the inline friend function. This is, I haven't put an inline, but please excuse me for the slide code, is called hidden friends, and is hidden in a sense of it's hidden from the global name lookup. Cool. So now we get the behavior that we wanted. So let's summarize the characteristics of this method. So porting functionality from spaceship, basically user namespace, into the lib space, done. This is not intrusive to the library space. It is intrusive to the user. So the user need to opt in into that, but that's also fine. And we basically trust overload resolution to locate the correct candidate. Not great in my mind. And of course, it's based on names. So yeah, if you ever try to do std swap, yeah, that is the way to specialize this for your type. But I think we're gonna, you should probably use just ranges swap. So as I mentioned, this paper by Eric Nibbler was setting the terminology for customization points for exactly to address this method. 25 minutes, but I think I'm fine. And Eric mentioned two problems here. First is that the calls within the library needs to be unqualified. You need to basically, if you're looking at the right side, you need to do using std swap for, opting in into this whole mechanism, a great mechanism of ADL and etc. But another problem is that if users wants to do something, if they wanna have this utility, they also need to be able to do those things in their application code, which is, I think, quite horrible, because we're now there's unwritten information needs to be passed, and yeah. So to solve those potential issues, Arik basically presented customization point object, which is heavily utilized in ranges. So let's go over customization point objects. Any questions so far, by the way? Yeah, go ahead.
What do you do when you want to turn on the argument dependent call for something like swap, not within a block context, like the implementation of a function, but for spinning conditions or...
This is doing it for Sphena. It's not in a block. The user space is this is imported, right? This is the library, the defining the friend function is in the encapsulating namespace, and then the encapsulating namespace includes the library, standard library header or something. It can be...
Yes, let me formulate the question. Let's say that you want to invoke swap. You want to distinguish using an spinning condition that you are able to invoke swap
Okay.
in your function, okay? That is not
Oh, you need to do what I've shown in the previous slide. You need to do this, using std swap, then swap.
Yes, but you cannot do using std swap in the spinning condition itself, you see? That's
Okay.
the question. I think it is not possible.
Okay, I'm not sure I understood your question. What does it mean in the Sphena condition itself? But I have a lot of... Okay, yeah.
That is not a block context. So it's not a place where you can do using a standard swap.
Oh, I see what you're saying. Okay, yeah, I agree. It's a downside. I agree. I mean, what do you do? I'd say you don't use this. You use the other methods that I'm going to show. I agree. It's not solving the problems that we have. All right, cool. But thank you for clarifying that. I needed some time to. So customization points objects. This is the alternative, right? Hopefully. One of the alternatives, at least. One that we have. So now we're in the library namespace defining this log function default. And we defined this object, log func object, basically calls the operator parentheses. And we do std forward. Again, ignore slides code. It's a very simplified one. But basically, we define this on the library space. And library creates this log func functor. Okay, so this is a class with operator parentheses. Library creates this global log func. We need to basically have this complex way with static const that returns the internal member of the class, basically to be able to overcome ODR violation, one definition rule violation, because we're trying to capture here the log name, and we have a function called log, and this may clash, right? The compiler doesn't like this. So we do this magic, behind the scene magic, to basically define this functor to be able to forward. And again, if you want to know more about it, the one in the corner is basically containing the specific example of how to do it. Actually, the last slide that I have is swap, customization point object by swap, swap by customization point object, so I can, if I have time, I can show it. User creates this log accepting spaceship, right? And now we magically don't need to do the std, using std swap, etc., in order to call the right implementation. So basically, this is a way to overcome limitations that we had before, right? It's not perfect, but it does provide this. The log that you see for spaceship, log s, is basically going to be ported back to the functor. The functor is going to call the forwarded thing in the bottom, and we're going to get back to the log spaceship by the user. Cool. So porting functionality for user type into the lib space, that's great. Non-intrusive into lib space, it is intrusive into user type. And still we capture names globally. We do it in a more complex way. And there's involved some complex mechanism to avoid ODR violation, but again, I don't think it's the major point here. And examples of those, as Shaha and as Federico asked, right? Federico, sorry, Edward. Yeah, sorry. Is ranges swap, ranges begin, etc. So this is being utilized for ranges. Cool. So I have 19 minutes, I think I'm fine. Let's talk briefly about concepts. So concepts been introduced in 20, of course. We have a log type, and this log type, using concepts, you can basically limit the types that get into your algorithm, right? But you can, this is limited, right, by semantic notation. Like you can basically check if you have, I don't know, a name function, right? But you can't check everything. You can check more complex logical code. This is a limitation. So one way to use concepts to overcome this limitation is to define tags. So basically, the library defines this logged type tag, right? And log type have to have this tag instantiated. Yeah. And then we have the log function that takes a logged type or over a different overload that doesn't. And the user have to define this type, this tag within the class, right? And this is the secret for basically saying I'm opting in and I'm a type that can be logged. And this is, again, this is not as great as, I mean, you can't achieve everything with regular concepts, so you sometimes need to use those tags, but it's still better than what we had before. So it's clear in my my opinion, concepts are clear. It's not namespace or type intrusive. You still need to reserve name. You still need to reserve names, but library needs to be able to use the concepts in order to actually utilize them to things that are more complex than just checking, some conditions or whether we have name function. Still useful, but so that's again, as I said, for syntactic conformance, it's great. For semantic conformance, you need a bit more work. Still can be achieved. And as I mentioned, ranges also heavily using concepts. So we've now summarized what we have right now. We move into 3 different methods, and I'm going to scan briefly because, first of all, they're not actually in the standard yet, and second, I think there's still open discussions there. But I just wonder, let's do a hand vote from 1 to 5. Let's start with 1 and just vote for your favorite customization point method. So who's for inheritance? Is that true also if you don't care about like runtime and virtual table? I'm sincerely asking. Okay, that's good. Who's up for class template specialization? Cool. Original customization points, so basically friend function, ADL, etc. Cool. All right. Customization point objects. The one that proposed by Eric Nibbler, cool. All right, and concepts? Who like concepts for this problem? Wow, okay, so I think we have a winner. I really think concepts can achieve a lot, but yeah, there's a lot to be done. Let's move on. So tag invoke was considered for 23, but didn't make it into the standard, and you're gonna see why soon. Tag invoke is basically a mechanism to utilize tags in order to opt in into implementation of library. It's very, if you've been reading code in C, I think it'll be familiar to you because sometimes you can basically use the first parameter of function and define the tag there or something like that. That's, but I think it's also widely used in different industries. So let's go over this quickly. And again, this is a complex mechanism. This is actually the simplest example that I could find. Implementation by, I can see a guy rolling his eyes. Yeah, tag invoke is a complex mechanism. Yeah, this is by René Rivera Fernandez Moral, but the mechanism proposed in P1895 by Louis Baker, Eric Nibbler, and Kirk Schrupp targeted 23, didn't make it into the standard. And the example is based on duck invoke, which is the simplest one I could find. And Eric Nibbler also have, by the way, implementation for tag invoke. So we have here basically a lib space, and lib defines this tag, log tag. So now everyone that wants to opt in order to be logged need to address this log tag, as you're going to see soon in the user side. But this is something that the library says. It's a terminology, right? Right. And this is a macro that we're going to see soon what it opens to. So let's vanish the macro thing and just see what we get. Very similar to what we saw for customization point objects. We're trying to capture the name. So we're defining this static struct, and we're returning what we want. And we now delegate to this log tag. So let's see how it works. User defines functionality. So we have, as you can see, the first parameter of log velocity and log fuel for spaceship is log tag. So that's the way for the user to say, I want to be logged. And then a function also needs to be called tag invoke, which is a preserved word. So if we would have suggested that into the standard library, we need to preserve some word. It didn't have to be tag invoke, but we needed to preserve some word so the user can say, I want to opt in into this mechanism. So let's say we call log with log velocity as the first parameter, and we give the parameters 4 and 2. Log velocity is the tag, okay? This is the type. This is being resolved by the type. Log velocity goes there to our function being implemented by the library. Log, the first type, okay? And now we forward to log tag. We use the complex way to overcome the ODR. And we call the struct. And then throughout this complex process, we go back to log velocity. So we called log with log velocity, and we get back basically the library knows to call log velocity function, struct. The tag invoke function within the log velocity struct. And if we do the same for log fuel, we get log fuel implementation for tag invoke with the log tag. So let's say if I had a different library, not logging library, but I don't know, fill fuel or watch movies, the tag invoke, we would still need to write tag invoke, but then you'll give a different tag. It wouldn't be log here. Sorry. Oh, cool. It wouldn't need to be log tag, the thing that the library defined in order to tell you to opt in into logging. It will be, movie watching library tag or whatever. Yeah. But I think you'll agree this is complex. I think this is actually the most complex methods that we saw so far. So it solves some of the previous limitations that we saw, but this is a complex mechanism. And again, we need to somehow tell the users, use our thing like that. And communication is limited. Diagnostics are very complicated because, as you've seen, there's template instantiation involved in the process of overload resolution, things like that. And compile time performance is not great. When this was proposed, by the way, it wasn't known. Then later, it was known. So yeah, libunifx uses this. And earlier versions of std execution, if you heard about sender receivers maybe, which is something that's being considered for 26, async framework, then earlier versions were trying to utilize tag invoke, but as you can see, it wasn't great. But the reason I'm showing you tag invoke is because we actually do have something that I think that is answering all the issues and behaving very similar. It's not in the standard, but it may be for 26. So what I'm talking about is customizable functions. So this is a paper being proposed by, first by Matt Celebrate a few years ago, and then again, the similar thing, of course, being reiterated, was proposed by Louis Becker, Corentin Jabot, Jasper Asman, and it started in 26. And the idea is, you liked inheritance, right? You liked, the expressiveness of that. So what we get here is basically a template, right? This is a template function. It's not regular function, but we have virtual keyword. And this doesn't mean that it goes through a virtual table. It means that we're basically saying, it's behind the scene, this is just like tag invoke, but it's not being done in the library, it's being done on the language. And what we're saying is, we want the users to implement this functionality, pure virtual functionality, right? Just like we know. And these ones actually have some default implementation, and that's why we use the keyword default. Cool. Users basically write their function like this, and then we get the proper behavior. So I think you agree with me that this is simpler than tag invoke. I can see some people nodding. I like this. I think this is the right direction. We haven't actually been fully processed. We haven't actually fully processed this. I would hope that we'll continue the discussion, because I think this is something that we need. And by the way, the original paper that I mentioned before, the one by Barry Rasvin, it's called "We Need a Language Mechanism for Customization." So maybe this is the one. So user can implement a hidden friend, and I think this is way more readable, right? This is looks like something that we know. By the way, the syntax here is the one that's being proposed. It's not necessarily the one that's going to be accepted, but I think it's like, just by looking at this example, it really is shines the fact that this is something that looks familiar. And it basically solves a lot of the issues that we saw in the previous slides. Downside, in my mind, is that it's not in the language yet. Yeah, and examples, so state execution already passed. We're going to have to see what happens, but generally speaking, future libraries, if we're going to get this, are going to be able to use, and I think it's great. 1 second, Chaha.
Where did log fuel and log velocity come from? Before they were part of the specialization, now they seem to be part of the library.
Yeah, I've kind of mixed that now, just in this example, so I'm sorry for not being consistent with the previous examples. Imagine that those are library provided. I don't know, it's a vehicle, and you need to be able to log velocity and log fuel.
But before, you didn't need to handle that in the logger library.
Yeah, it's not a logger example. Forget about, put aside the logger example. This is a different example for showing how we can provide something from the library and then...
So it should be pointed out that this solves a different problem.
Right. Not the method. It's just this specific example has been, I thought it was more simple to show like this. If you want, you can imagine that this log velocity is log, and this is, I don't know, log, let's say log velocity, it's log for something that's, yeah. But in general, yeah, I'm sorry for not being consistent with the other examples, but in general, it's still doing the same thing, right? It's like we have a default implementation. This is the library side that doing something, and we have the ability to overload this by user. But yeah, it's not that the method is solving a different problem. It's just this particular example. It's important to emphasize. Yeah, so we have 5 minutes. Let's do this quickly. So reflection is also not in the standard, but I don't want to go into reflection. This is not a reflection talk. But generally speaking, you could imagine that reflection is allowing you to take something from the user, a spaceship class, and break this into parts. Basically, a logging library could do something like check for name or, within reflection framework, right? So this is very, very powerful. And some people claim that this could be the solution for customizations between library and user code. But I'm not sure I agree with that, because I think this is an overkill. I think this method, and this is actually blocking some of the process for other things like customizable functions, or maybe alternatives that we may see in the future. I don't think it's definitely the right approach, because reflection, you can do anything with reflection, figuratively speaking, but you don't want to do anything with a very, very complex overkill mechanism. But again, this is how you see this, and this is from the P2237, which I think is structural copy example thing, and I modified it for fitting to log. I think this is the paper that is most advanced in reflection world. But yeah, technically you could. I think we should. Yeah, it's a very powerful tool. So to summarize what we saw here, first of all, this is a table trying to show all the different methods that we saw and compare them with different characteristics that we saw. If it's my view of this, but maybe you think otherwise, that's perfectly fine. But at least I was, trying to show you, and I also marked concepts because I'm not sure if it solves all the use cases as the other ones, at least. But as I mentioned, this is part of the thing that is designing a library, and there's a lot of other things. So I just want to very briefly go over those. There's error handling, there's defaults, right? Not necessarily all the defaults that library authors think are the correct ones for users. There's global effects, like we saw, capturing names, ADL, etc. This means something when you get two different libraries. It means something if you capture a name, right? Might clash. There's runtime flow, execution model, etc. Documentation, which I think is very important. So we have, there's a very good talk from Core CPP, which is the conference I'm involved in organizing, by Marshall Claw, which have been writing libraries for 30-something years, both for Boost and for the standard library. And I think this is a great talk addressing a lot of the other things that I haven't addressed here, which are important. So check that out. So Stewed execution did not make it into 23, maybe into 26. The discussion about, changes in the customization mechanism, one of the reasons that, it's a very complex paper, but one of the reasons it's so complex is that you have a lot of customization points. And this is a major discussion. Tag invoke was considered for 23, but was dropped due to language support for customizable functions, which is now been delayed due to possibly reflection. So I would hope that we're going to get to at least some of those solutions. And I was more optimistic in the previous time I gave this talk. I wrote here 26, now it's 29. But maybe we'll get at least some of them. And I think, as again, customizable functions or an equivalent solution that is similar, I think are important. And meanwhile, we'll have to settle with non-language solutions and rely on the things that we saw in the presentation. Thank you for listening. Yeah. Wow. I have 40 seconds. But I can't believe I made it for the field. Okay, I want to mention a few people. The talk is based on We Need a Language Mechanism for Customization Points by Barry Resvin, a very important paper I would recommend everyone to read. Tag invoke by Gasper, there's a talk about it, and I know I've been presenting it. Maybe I wasn't presenting it very well, but that's my opinion. It doesn't mean that everyone feels the same. If you want to learn more about this mechanism, feel free to. And suggestions design for customization point, which I mentioned. A lot of talks and references, and what just happened. And I do want to put on the slide, sorry, in the background. Okay, hope you can see that. Okay, this is the CPO for swap. If you wanna, I know if you wanna read, I'm sorry, this is not a slides code because, but if you want, feel free to go into the presentation and use the links. Right, I would like to hear your opinions, not questions, but opinions. Because, feel free to ask questions, but any comments or what? Oh yeah, and if you have any comments or thoughts of this, feel free to come to the mic. Oh, please. Hi. Yeah, sure. What's your name? Sorry, I need my glasses. Hi. Hi. I'm sorry, I couldn't recognize you by the.
I was just going to ask, why is reflection delaying the awesome solution to this problem?
I haven't. Yeah, you need to ask. Yeah, I get it. I get it. That's a good question. There's a lot of work on our plate. Reflection is important to a lot of people. We know that, and we're trying to deliver. There have been a discussion. I don't want to, go by names or anything, but some people were concerned that we're basically duplicating a solution, like giving a solution that we're going to solve later, and maybe we don't need this. I don't think it should. It's going to have to be discussed by evolution work group. I don't think it should, to be honest. Yeah. Other questions or comments? Go ahead.
Oh, hi. Have it been considered how swap the class template and then the ranges CTO, if the new thing comes in, what happens to the old customization? Is the evolution part of the consideration when we're looking for a new solution?
So it's not simple because you can't. There's a lot of the idea of dropping old things is very complex for the standard for C++. Particularly, we want to support. We want to have long support time for all the things that we publish. It means that you can't now just modify existing things to the new thing, not easily at least. But just to address your question, so I'd say, for example, use ranges swap if you can instead of stud swap if it fits your, yeah.
So I think for the methods not reserved global name, that's the future concern where the name is forever preserved.
Right.
Yeah, I don't have any suggestions, but it's pretty painful.
Yeah, I agree. Global namespace, preserving names is part of the things that you have to do in order to use our overload resolution, right? This is an integral part of the method. Yeah, I would hope for us to have something better. Sure. Hi. Thank you, everyone. Yeah, go ahead.
So I think the class inheritance is the simplest and easiest. Very weak.
You're talking about the first. Okay, yeah, I agree.
And it's being very readable, easy for new developers to come in and triggers performance trade-off.
Right.
There's an argument for that maintaining.
Right. By the way, CRTP I didn't mention, but compile time inheritance, I'll put it in the same, I address it the same because it's still but even though the mechanism is not as clear. So it depends on how you look at it, but yeah.
I think CRTP is different. I like CRTP.
Yeah.
But I think what really got me interested in Method 5 was there was a talk from Ben Alpha, previous CppCon,
Sorry, I forgot which one is 5. Oh. Oh, tag options for concepts, right.
Basically concept.
Right,
And it was really eye-opening to see the presentation. It was a 2-hour presentation. Dive into how all of that works.
right,
Concrete example that are, different images from
right,
on how to do it. And some of these other things, I'm sure there's presentations on it.
right, yeah,
I think that goes a long way to describe my best. My opinion on this, why I like fun.
right,
If I'm talking to a user, I highly recommend push deep and look at something more complex. You're going to be sort of worried about.
right, right. That's a good. Thank you. That's a good comment, by the way. Thank you so much. And yeah, I mean, it's not like a simple solution. So, but I like the fact that you guide people to do that. So thank you. Go ahead. Sure.
In regards to customization point objects, especially for functor
example. Is it sort of like standard, at least with the state of C++ right now, to have stateless CPOs?
Right.
Or what's the sort of like coupling with the user space objects that we ought to have?
Are you asking if it's recommended to have stateless CPOs?
Stateless
or?
CPOs.
Really depends on what you're trying to achieve, but like the general answer would be yes, unless you really need the state for some reason. It's basically something that the library, it's coupled tightly with what the library is trying to do, right? Mm-hmm. Like, I mean, you could technically put state in this, it's a class, but do you want to, I don't know, maybe it's a pitfall for your users. It really depends. It's kind of hard to answer that.
Yeah, I guess at that point, inheritance would be more attractive because of the runtime information.
Yeah,
overhead you're putting.
that's true. Thank
Sure.
you.
Thank you.
Sure. Yeah.
Thank you. It was an interesting talk.
Thank you.
And really just a comment that as I was going through the different methods of trying to see which ones I like, it's the inheritance concept and customizable functions. And really what I found that they share in common is the documentation aspect of it, which is just so important.
Readability. That's
yeah,
what you're
exactly.
looking for.
When you're writing
I agree.
libraries read by other people, even though there are technical aspects as well, I think the documentation is just such an important part.
I agree.
I
I totally agree with you.
Yeah.
And I think like one of the most important things that I think is like there's a lot of aspects, but how do you tell your users to do the thing or not to do the thing, or
Yep.
how do you tell users? It's very important. This is the communication part that we keep missing when we try to use very complex and methods sometimes we're missing the user's perspective of, okay, I didn't wrote this library, I now don't know how to use it.
Yep.
And I think Marshall Clough actually did address some of this in his talk, which is great, really, for, if you write good documentation, then you can help. But still, I think that, it's something so basic to be able to customize library and application code, or library and user code is the basic foundations on which, we build programming languages. So,
Yep, exactly.
yeah,
All right, thank you.
sure. Yeah, please go ahead.
I think maybe this leads into the previous point, which is that it's really useful to be for a class, for a user type to be able to warrant that it does or does not, support this customization point and whatever associated customization points there are. And yeah, we would find it really useful for classes to be able to warrant this, and also to have very clear mechanisms for other user code to be able to determine whether or not these customization points are supported.
Right. So that's a very good comment. And I mean, if you have some thoughts, if you wanna email me, a general use case that you can see for that, and then maybe we can consider keywords for that in the standard for signifying that. That'll be great. Because I mean, yeah, I agree. All right. Well, thank you, everyone. I really appreciate your time.